Okay, in this third video now, we're going to look at, for Hadoop, we're going to look at Hive, Apache Hive, which really is a way of turning your Hadoop cluster, and remember I've only got a single node cluster here, but turning your cluster into a database, SQL compliant database, and then we're going to try and access that Hive cluster using standard SQL JDBC client. So first of all, I have to install Hive. I installed Hive 0.100 bin, and it follows the standard stuff. It's pretty easy to install, and there's a few variables you need to set, and it really is your Hadoop home and that kind of thing. But then there's a few commands you have to execute. So and there's a Hive home you have to show. It's .txt. So first of all, you would need to set this Hive home variable. Then you got to run Hadoop to create a few file systems to prepare for your Hive warehouse, and it's these commands. So you run Hadoop, file says make the temp, so Hive warehouse and a user warehouse, and then you change the mode so that they're writable and all that. So those are the commands I executed, and from then onwards, after executing that and setting that variable, start using Hive. And Hive, just like Pig, allows you to enter, and you can do something like show tables and execute that, and you can see it's blank at the moment. So from our previous video 2, we saw how we can import data and query it with Pig. So if I were to run Pig at the moment, like we showed in video 2, like I showed in video 2, and we see there's the data, the metadata, 10,000.csv, which we exported from the Million Song database. So now using, and of course in the previous video we could query that using Pig. Now we're gonna move on to Hive, which is a little bit more SQL compliant. So in Hive, what we're really gonna do here is we're going to execute. First of all, we're going to create we can do a few commands like show tables, and we can see that there's nothing. We can do a simple command like create a table. Let's just play around and create a table like that. Pokes, create table pokes. The detail behind here we don't have to really worry about at this stage. And now if we say show tables, we'll see that, hey, there's a pokes table, and now we can just say describe pokes, and it's a foo and a bar and an int and a string. So if I were to look at something like a file, something simple. So if I were to more data.txt, I'd created this little data file, and I see there's a 1 and so it's a int and a string. So if I in this one, it's got 5 entries. So if I run Hive, and I'm so first of all, let me drop table pokes. So I'm gonna drop that one. So as you can already see, this is very SQL compliant. So show tables. So there's a little bit of stuff here that's extra. So format, delimited, fields terminated, where it says it's going to be a comma separated file. So describe describe pokes would result in an int and a string, and now I can do my load. So I'm going to say load data from a local in path, the data.txt file, one we just looked at, into pokes, and there's done it. So now I can say select star from pokes, and hey, there's a few things. Now we can do select star from pokes where foo is greater than 3, and now we'll see that it starts, and this is what Hive does. It converts a SQL query like that into a Hadoop job. The Hadoop job is really for the MapReduce job, and so we can see that, you know, as it goes with MapReduce, and I don't know if I've shown this before, but MapReduce really has two parts. It's the mapping and a reducing part. So because I selected and said, you know, where foo is greater than 3, it really has to do a reduce part as well. So if we were to look at something like this, this is what MapReduce really does. You get the input, you split it in a cluster. At the moment there's only one cluster, so it does the mapping part there, and then it copies it over, and then it starts merging it, and then it starts reducing it, and then there's the output. So that's the idea behind MapReduce, and we can see that it did the map part, and then it did the reduce part, because there was a where clause in there, and my Hive converted my SQL query. Select star from pokes would be the map part, and the where clause where foo is greater than 3 is the reduce part. So, and that was the result, 2 entries. So taking this a little bit further and working with our Million Song Dataset, I created this little create table statement, which is actually quite a big one, and it's really something like that, and it really says, you know, create table, song metadata, and the same stuff, you know, title string, album string, artist string, duration, all of those things in strings and booleans in there, as Hive supports the primitive data types. So when it's done, it's created the table. Now we can say show tables again, and we can see we have pokes and song metadata in there. Describe song metadata, and there it is. It's a pretty big table with lots of information in it. And now the next step, of course, would be just to, you know, try and load that metadata.10million.csv file, which we acquired earlier from a Million Song Dataset. So we created the CSV file, and I'm going to load this into table song metadata. So the Hive goes off, and there it is. So now I really have a whole lot of data, 10,000 songs with all the data loaded into this Hive database. Now I can start doing simple queries like this. Select title, artist, year from song metadata where year equals 1986. You remember that in the previous video I did this with a pig query. Now I'm going to do it with a Hive SQL statement, and we can see again there's the map part, and we can see that in the job tracker, which is complete, and the reduce part, which went by pretty quickly because there was a where clause, and there's the song. And we can see, of course, it's the same output as yesterday, except now it's standard SQL queries. So taking this one step further, Hive does come with this product called the Hive JDBC server, and this guy, you would execute it like this: Hive minus service Hive server. So this guy will start up, and it's called the Hive Thrift server, I'm going to start up a standard client, SQL client. I particularly use Squirrel over here. So I've created the driver called Hive. You can see the details of this. It's Hive, JDBC localhost. The driver itself is Hive driver. It has quite a few libraries. We have to install the Hive libraries as well as the Hadoop libraries, but that's the driver name there. So, and then I created a little alias here, so to the Hive database, and I'm actually going to try and hit connect now, and hopefully, if everything goes well, it connects. So we can see that I have tables in here. There's my pokes table. If I look at it, the content, I can see, there's the 5 entries. So here's my song metadata. There we can see there's some data in there. So now I can start issuing, and remember, this is a standard SQL Squirrel SQL client. There's nothing too involved with this. I can start throwing nice little queries at it like we just did straight in the Hive console. I can go and hit something like select title artist year from song metadata where year equals 1986. I'm going to execute that against the Hive Hadoop database. It's going to come back in a few seconds. And remember that that Hadoop is batch based, meaning I've just submitted this job and it's come back with some results. I'm going to try and look at that result. There's some of the results right there. Of course that's for all. Of course you can go pretty wild at this point and start throwing all sorts of things at it, like for instance a query like this: select year from song metadata where year is greater than 2005 but year is smaller than 2009, order by year and artist. So again, when you hit that, it will start executing, looking at Hive itself. We can see that that job is now turned into a MapReduce job. It's finished with the map parting of it, the map part of it. It will now start with a reduce part of it. There is 100% with a reduce part. The result has come back, and if we look inside our little client over here, we can see, hey, there's some data. There's 2006 data, and it's sorted. It's all good. You know, this has been good. Thank you.